Before we get to the unit circle, we want to kind of transition from our original triangles to the circle triangles. So originally when we looked at it, we had a hypotenuse of 2, a short side here of 1, and a long side of root 3. Long side, short side, and hypotenuse. Well, when we transition to the unit circle, our hypotenuse is essentially the radius, and the radius is 1. So essentially what I did was I divided all of those by 2. Divided them in half. If I divide that in half, then the sides will be divided in half. I divide the hypotenuse in half to make it 1. Then the sides became 1/2 and root 3 over 2. So, say I used here to construct any trig function, sine 30. 1 over 2. If I was looking at, say, the original 1 over 2. 1/2. Well, it's the same thing for our unit circle, sine of 30. Opposite, 1/2 over hypotenuse, 1. And it still gives us 1/2. So the ratio is the same. We've just now shrunken our radius to 1. Okay. And I'm not going to get into the derivation here of the 45, but let me also just kind of put this idea in our heads. Oh, that won't work. Okay, and with the 45, 45, 90, our original triangle was here, and it also goes to a radius of 1. And notice the ratio was the same here, right, for sine of 30. Well, the sine of 45, 1 opposite over hypotenuse, root 2, and then I rationalize root 2, root 2, root 2 over 2. Well, that's going to be the same thing here too. So that becomes root 2 over 2, and that becomes root 2 over 2. Root 2 over 2. Okay, so instead of looking at the triangles in our original kind of viewpoint, we want to start looking at them in kind of a unit circle. Now the ratios are the same, whichever you use, because again here, sine of 45 would be root 2 over 2 over 1, which is root 2 over 2. So notice they're the same whether I constructed them from the original or from the unit circle. Unit circle or original, both are the same. However, we want to start looking at them each with a radius of 1. In other words, the hypotenuse is equal to 1. And so for a 45, each of the legs will be root 2 over 2. We want to commit this to memory. And for a 30, 60, 90, the short side will be 1/2, and the long side will be root 3 over 2. And remember, longest side across from largest angle, shortest side across from shortest angle. I'm going to go ahead and divide my circle into 4 quadrants. Let's start by labeling degrees. 0 degrees on my x-axis here. Positive x-axis is 0. 90, 180, 270, and back to 360. Correspondingly in radians, that's 0, pi halves, pi, 3 pi halves, and 2 pi. Let's begin by first making a 30-degree triangle in the first quadrant. Label your theta, 30 degrees. A 30 in the first quadrant is going to have the dimensions of 1/2, root 3 over 2, and of course the radius of 1. All of our triangles in the unit circle will have a radius of 1. This will refer to as our short side, and this will refer to as our long side. Okay, drawing a 60-degree in the same, let me go ahead and change colors. Put in your theta, 60 degrees. Now, notice for a 60 degree in the first quadrant, my short side and long side will be interchanged. So this will be 1/2, and this will be root 3 over 2. And of course, a radius of 1. Knowing these special triangles in the first quadrant is important for understanding once we move the angle outside of the first quadrant. So a 30, a 60, remember short side 1/2, long side root 3 over 2, and notice it's flipped between the 30 and the 60 degrees. Okay guys, let's now look at a 45-degree angle in the first quadrant. Some of this will be a little experimental as I get used to my computer program that does this. So bear with me. The videos will get better in time. Okay. Again, here's our unit circle. 0 degrees, 90 degrees, 180 degrees. 270 degrees, and back here to 360. Now corresponding in radians, that would be 0, pi halves at 90, pi at 180, 3 pi halves at 270, and back here to 2 pi. Radians and degrees. Okay, so if we look at a 45, go ahead and put in your theta. If we look at a 45 in the first quadrant, it has a radius of 1, and this side will be root 2 over 2, and this side will be root 2 over 2. As we learned before, a 45 degree, 45, 45, 90 would of course have legs the same length, and then in this case on the unit circle, we're going to have always a radius of 1. Okay. So that should complete the 3 special triangles in the first quadrant. Remember, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Notice in the first quadrant, both my sides are positive. Okay.